In this video, I want to make a point about proof by induction and how we need to avoid doing circular proof. So I'm assuming you have seen proof by induction before. And if your teacher has made a comment that you are doing circular proofs, here is what we mean. So we've got this quite funky proof. We're going to first off consider, is it true for n equals 1? Now, a circular proof would be to say that the sum from r equals 1 to 1 of 3 to the power of r would be so it would be this, 3 to the power of 1 minus 1. And then we'd say, well, that is 3 to the power of 1 equals 3 on 2, which is then 2. 3 equals, no, 3 equals 3. And we go, yes, that's correct. However, that is not how we do proofs. That is what we call a circular proof, because on this very first line here, we have assumed the thing we are trying to prove. So and if you do that, I mean, we could just write down any old garbage, something equals something, and then say times everything by 0 and say 0 equals 0. And then we can say, hey, we've proved what we wanted because we ended up with a true statement, 0 equals 0. So bad. What we do instead, we say when n equals 1, sum from r equals, sorry, left hand side equals sum from 1 to 1 of 3 to r equals 3. Now from here you've got a choice. It's not obvious how you would go from the left-hand side to the right-hand side like you would in the bit that's coming up later. So instead we can then write over here, right-hand side equals 3 over 2. 3 to the power of 1 minus 1, which is 3 over 2 times 2, which is 3. And then here we can say that equals the left-hand side. So now we've shown both of those two things are equal to 3, so they must both be equal to each other. So this is good. Okay, that's what we're after. Now let's say how we would, while we're talking about induction, it seems like we should probably just look at the rest of it. I like to see the line that says assume true n equals k. So we are assuming that the sum n equals 1 to k of 3 to the power of, sorry, I don't want to put n there, r equals 1k, 3 to the power of r equals 3 on 2, 3 to the power of k minus 1. And now I'm going to write down the thing I want to prove, which is the sum r equals 1 to k plus 1 of 3 to the power of r. Now it's okay, this one we can write as 3 to the k plus 1 minus 1. We can write this, that's fine. But what we can't then do is say, well, from here, this is 3 on 2, 3 times 3 to the k minus 1. And over here, this is the sum of r equals 1 to the k of 3 to the power of r plus 3 to the power of k plus 1. Again, this is a circular proof because we have assumed the thing we are trying to prove. So we do not do that. What we do is we say the left-hand side equals. Now I'm going to go straight to the line I've got up here that I've just crossed out. R equals 1 to k plus 3k plus 1. So there's no both sides of the equal sign in this case. We're just saying, well, left-hand side equals this, which by assumption equals this. 3 to the k plus 1. And from there, we carry on and we keep doing stuff until we get to blah, 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 equals 3 on 2, 3 to the k plus 1 minus 1 equals the right-hand side. And that is the right-hand side of this statement up here. Okay, so that's the lesson for this little video. Make sure we are not writing circular proofs because examiners at best will tolerate them for the n equals 1. For the main body of the proof, you will lose most, if not all, of the marks, and we don't want to do that.